All right, let's talk about the device you're probably holding in your hand right now, your phone. It holds, well, everything, right? Your bank, your private chats, your whole life, and we just sort of trust it. But should we? We're going to dive deep into what's called the Android paradox to hunt down the single biggest flaw in your phone's security. I mean, you know the drill. You get that little notification, system update available. You tap it, it installs, and you think, great, I'm safe for another month. It's a nice, comforting feeling. But what if it's just that? A feeling. What if the real dangers, the biggest dangers, are things those monthly patches can't even touch? So this is what we see, right? A friendly green checkmark. System is up to date. All good. But what's really going on under the hood is, well, this. A hugely complex web of hardware and software from dozens of different companies. And buried deep inside that complexity are what we call architectural flaws. These aren't just little bugs, they're cracks in the very foundation, and you can't just slap a software patch on a cracked foundation and hope for the best. Okay, so to get to the bottom of this, we're going to put three main suspects under the microscope. Three contenders, all vying for the title of Android's biggest flaw. First, we've got a super clever invisible thief. Then there's the forever bug, a zombie that just won't die. And finally, the most mind-bending of all, a flaw that's actually a feature. All right, let's start with contender number one, the invisible thief. And honestly, this one sounds like something straight out of science fiction. We're talking about a bug that can literally read your screen, see everything you see without having any eyes. It's a ghost in the machine that just waltzes past every security guard Android has in place. So you're probably wondering, how is that even possible? Well, it's because this isn't your typical software bug. It's a totally different beast called a side channel attack. The best way to think about it is like this. Imagine you're a spy and you're trying to figure out what's happening in a locked vault. You can't break the door down, but you can put your ear to the wall and listen to the clicks of the tumblers. You're not attacking the lock directly. You're exploiting the side effects of how the lock works. That's what a side channel attack does to your phone. This specific attack has a name, pick snapping. And here's the part that should really make you sit up and pay attention. It lets a malicious app, that free game you downloaded or some random utility, read everything on your screen with zero permissions. I mean, literally zero. It doesn't ask for screen recording, it doesn't ask for camera access, nothing. It just does it. So, how in the world does it pull off this magic trick? It's a 4-step heist. Step 1, the malware throws an invisible layer over, say, your banking app. This layer has a tiny little pinhole, a keyhole. Step 2, it then tells your phone's graphics chip, the GPU, to do a really hard job, like a heavy blur effect, on whatever's visible through that tiny keyhole. Step 3, and this is the genius part, it times how long the GPU takes. See, a GPU takes a fraction of a millisecond longer to blur something complex, like the number 8, than it does to blur something simple, like a blank white background. Finally, step 4, the malware does this thousands of times per second, moving that little keyhole all over the screen, measuring those tiny time differences, and it uses that timing data to perfectly rebuild the image underneath. It's insane. So what's at stake here? What can it actually steal? Well, basically anything that ever appears on your screen. We're talking two-factor authentication codes, your bank balance, your password manager, even your so-called secure private messages on Signal or WhatsApp. And that's the real kicker here. You can have the strongest encryption in the world, but it doesn't matter one bit because pick snapping doesn't try to break the encryption. It just waits for the message to be decrypted on your screen and reads it over your shoulder digitally. Game over. Okay, so pick snapping is, wow. It's a devastating flaw baked right into the hardware. But our second contender says, hey, having a nasty bug is bad, but what's even worse is a system that can't fix it. This brings us to contender number 2, the forever bug. This is all about when a patch isn't really a patch. And this timeline from a real-world case lays out the problem so clearly. Look at this. In January, a serious bug is found and reported to Qualcomm, the folks who make the chip. By May, Qualcomm has a fix and sends it to phone makers like Samsung and Google. So, problem solved, right? Not even close. For the next 7 months, from June to December, hackers and spyware were having a field day, actively exploiting this bug out in the wild. The public wasn't even told about it until December. And for most of us, we didn't actually get the update on our phones until early the next year. That massive delay, that's the patch gap. And this gap has a name. Researchers call it a forever day vulnerability. You've probably heard of a 0 day. That's a bug no one knows about yet. But a forever day is almost worse. It's a bug that's been discovered, it's been fixed, the patch is out there,
but it just doesn't make it to your phone for months or even years. It's this zombie bug that just keeps shambling on, a permanent weapon that attackers can use because they know most people are still vulnerable. Now for our third and, frankly, most unsettling contender. This one's different. It's not a hardware flaw. It's not a bug that can't get patched. What if the biggest flaw in Android isn't a flaw at all? What if it's a feature? A vulnerability that's there on purpose, because getting rid of it would just be too much trouble.
This quote really nails it. Let me read it. Android has codified a level of permissive insecurity that malware authors have learned to exploit as a reliable feature. Permissive insecurity. Think about that phrase. It means these aren't accidents. These are conscious decisions, known issues that get labeled won't fix or intended behavior. And the bad guys, they love this. They can build their attacks around these features because they know they're not going away.
But why on earth would they do that? Well, it usually boils down to this constant battle between security and, well, convenience. Here's a perfect example. From a security point of view, it would be great if no app could see what other apps you have installed. That way, malware couldn't snoop around and see if you have, say, the Bank of America app to target. Simple fix. But the problem is that would completely break things we use all the time, like the Share To menu. That menu needs to know you have Twitter or WhatsApp installed to show you the option. So Android is forced to make a choice. And more often than not, usability wins, and that security risk just gets accepted.
And this isn't a one-off thing. This won't fix philosophy applies all over the place. We're talking about weaker memory protections that make it easier for hackers to take over the whole phone. Loopholes that let malware build a profile on you by seeing which apps you use. Even ways for attackers to pop up a fake logging screen right on top of your real banking app. These are all known, documented issues that are basically treated as the cost of doing business.
Okay, so there are our three contenders. The Invisible Thief, a bug that can read your screen, the Forever Bug, a problem with the whole patching system, and the Flaw by Design, a vulnerability that's basically a feature. So, what's the verdict? Which one is the single biggest flaw?
Well, here's the twist. The biggest flaw isn't any single one of them. It's all of them, working together. The biggest flaw isn't a bug. It's not a piece of code. It's the entire system. It's how these three problems feed into each other to create a perfect storm. Let me show you what I mean. This is the toxic combination. You start with something like pic snapping, a deep architectural flaw that's really hard to fix with just a software update. Then you layer on the Forever Bug problem, which guarantees that even if there is a fix, you won't get it for months, leaving that door wide open. And the cherry on top? The won't fix culture, which gives attackers a reliable, stable playbook they can use because they know certain weaknesses are just part of the landscape. See how they all work together? It's a vicious cycle. So that sounds pretty bad, right? But it's not a lost cause. The question is, if more and more software patches aren't the answer, then what is? The real solutions have to be built into the hardware itself, into the silicon. We're talking about technologies like memory tagging extension, or MTE. The simplest way to think of it is like a bouncer for your phone's memory, checking the ID of every single request. It can shut down whole classes of bugs at the hardware level. The other big idea is better isolation, using something called virtualization. This is like building powerful firewalls inside your phone's chip, walling off different parts from each other. So if a hacker breaks into your graphics driver, they're trapped there. They can't get to the rest of your system. And that brings us to the big final question we have to ask ourselves. We've been trained to believe that monthly security patches are what keep us safe, but we've just seen how they're not enough to fix the deepest problems. So, if the fundamental tool we rely on, the software patch, can't actually solve the core issues, is our entire idea of phone security already obsolete?